Yeah, good evening, everyone. So, John again, so let's start off. Let's see. Hope everyone has registered on the site and you have seen the practice paper. Did you see the sample paper? Right. If someone has not registered, do that and ping me for the access because the test will be online on Thursday. Great. Others, do keep your cams on. Siddharth. So we'll be starting with a new chapter. Yeah.
Right. Switching on the camera, right?
Yeah, do switch it on once it is sorted. Let's see. Then okay. Let's see. So we'll be starting off with vectors. So what is a vector? So before jumping into that, let's define something. We need to define something called a physical quantity. So what's a physical quantity? So any quantity that can be observed and measured in an experiment. Right? It's called a physical quantity. Example, let's say work, force, temperature, etc. Like any quantity that you can measure and observe. Now, for example, see, let's say you see a snake. Are you scared of it? You see a scorpion. Are you scared of it? So can you tell me by what factor are you scared of the snake compared to the scorpion? Let's say when you see a snake, if your fear is X, when you see a scorpion, is the fear X by 2, X by 3? What exactly? You're getting the problem? You can observe fear in an experiment, but you can't quantify it. You can't measure fear. Getting this? Let's say you didn't eat food for one day. You're hungry. What if you didn't eat food for 2 days? Will you be 2x hungry? You're getting the point? So there are quantities which you can measure, but you can't quantify them. Right? So we also have something called non-physical quantities. This we don't study. Non-physical quantities like, let's say, fear, hunger. No, these are all quantities which cannot be measured. You can observe them, but you can't measure them. Now, physical quantities can be classified into three types. Meet, do keep your cams on. Scalars, vectors, and tensors. Now, tensors we don't in the portion. We won't be talking about them much. So if you're a mechanical engineer or a civil engineer and engineering, then you will study about them. So what's a scalar? So scalar is simply, quantity which can be defined with magnitude only. It's like asking how many apples you need. You'll say like, I need 3 kgs of apple. I need 2 kgs of rice. So you don't need to give any direction. So there's nothing like 2 kgs east and 2 kgs rice to the west, right? So example, distance, speed, energy, etc. So these quantities, right, require only magnitude. You don't need to define any direction as such. Clear? Next thing. Easy stuff. It's all just definitions. There's nothing there. Next thing, what's a vector? So vector, it's a quantity which has magnitude, direction, and the important thing, and obey vector laws of addition. So it has to satisfy 3 conditions. It has to have magnitude, it has to have direction, and it has to obey vector laws. I'll tell you what it means. Example, velocity, force. For example, if you take current, current has both magnitude and direction, but it is not a vector quantity. Think about it. Let's say if you apply a 10 Newton force, and if you apply a 10 Newton force, what is the total force here? If you're pushing with 10 and pushing with 10 from both the sides, what's the net force? 0, isn't it? But if you take current, let's say from this side, 10 amperes of current is flowing, and from this side, 10 amperes of current is flowing, how much current comes out? 20 amperes, isn't it? This is what I was saying. It doesn't behave like a vector laws are not valid. It has direction. The current has direction, right? It is flowing 10 amperes to the right. This is 10 ampere to the left. So you can define direction, you can define magnitude, but the current doesn't obey vector laws. So here, if you see, the net current is not 0. So this does not obey vector laws. So for something to be a vector, right, it is just not magnitude or direction. It also has to obey the vector laws. Clear? Please have a look at this. Devansh, do keep your cam on. Just let me take your attendance. Great. Clear with this? So be careful. Huh? Current is not a vector quantity. So now similarly, if you see area on the other hand, area is a vector quantity. Even though area looks like magnitude, all clear with this page, right? Yeah, again, don't worry writing about the notes, you'll get the PDF. So let's focus on listening, understanding. We will be doing problems, so focus on that. Area is again a vector quantity. So if you see, how is area a vector quantity? You need to understand one thing. My maths teacher, right, when he was teaching me, our maths teacher was quite old that time. So these people didn't have an idea about vectors. Before 1990, right, there's no chapter called vectors. People are using vectors in everywhere, but there is no formal chapter called vectors. Then these people decided was, We are using something, this directions and all, but we need to formalize this. And that is when they created this chapter called vectors. You need to understand. So vectors was, a human invention in order to understand and explain stuff, right? So who is missing? Chanakya, right? So the advantage is defining area as a vector helps us. So how do we define area as a vector? So whenever you have a plate or something, later on we will study this in called cross product. If you have already done that, you will realize A cross B is actually an area of a parallelogram. That's a vector. So we define area vector as perpendicular to the plane. So this is how we define area bar. We will define what is that bar and stuff. So for surfaces, we take area vector ka direction is perpendicular to the surface. There is a reason why we take it as a vector. People observed this quantity keeps popping up at multiple places. Then they said, yeah, defining it as a vector makes more sense. You could have taken it either side. You could have taken it down also. There's nothing wrong. We can choose either up or down. But for closed surfaces, I'll tell you what is the advantage of taking this as a vector. Now, when you say closed surfaces, maybe let's say we are taking like a normal, the outward normals are taken as positive. Meaning, if you have a sphere or if you have a cube, so whenever you see a figure like this, these are closed figures, meaning everything is closed. You can't enter inside without passing through the surface. So we take surface as normal again. This is how it looks. It's like away from the center, radial. That's still perpendicular to the surface. So for this thing, it will be out. For this guy, it is out. For this guy, it is down. For this guy, it is this. For this guy, it is this, and that is backward. What is the use of taking it as a vector? Think of like this. Let's say you have your room. There is a door here. There's a sensor there. Okay, there's a computer program sensor there. Now, if this sensor measures people like this, if every time someone enters inside and goes outside, the sensor gets on. Now think about it. If you take area as a scalar, what will the sensor do? If a person enters, it will count to 1. If person leaves, it will count 1. If person enters, it will count 1. If person leaves, it will count 1. Let's say if 20 people enter and 30 people leave, it will count 20 plus 30. What did you get? You got number of crossings, isn't it? It is of no use. The data is actually mostly garbage. But imagine if you define the outward is positive and inward is negative. If 20 people enter and 30 people come out, then it will count as minus 20 and plus 30. So we will know the net number of people who cross the door, right? What if you're standing near the door and you're jumping around, okay? You're jumping in, jumping out, jumping in, jumping out, jumping in, jumping out. If it is a scalar, the machine will count like this, 1, 1, 1, 1, 1, 1, 1, 1. But if it is a vector, it will count plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So it really doesn't matter how much you jump in and out, isn't it? So defining area as a vector, you have an advantage. You can count the total number of people entering or people leaving. Is that making sense? But if you make it as a scalar, the data is actually garbage. What you're getting is simply like there might be a guy here who's jumping in and out and he creates fake data. Getting it? Meaning when I say fake data, think of like this. Ever seen this thing? When you're going on highway or something, you Google Maps, if you open up, it shows traffic. So this one guy, what he did, he brought some 100 mobile phones. He kept it in a small trolley, right? All GPS on, all Google Maps on. He started walking in front of the Google office. Now, what will the system detect? The system will think there are 100 cars going on that road, right? At a speed of a person walking, isn't it? So when he opened the Google map, he found out that entire street was painted red. Basically, you sent wrong data to the system, right? The system couldn't recognize between 100 mobile phones in a trolley and 100 cars. Getting it? So that is one way to divert traffic. So what happened now? Because there is so much traffic, whoever is opening Google Maps, it is showing that area is blocked. So no one was coming into that area. So what you need is just 100 mobile phones or something, and you can fake the data, switch on all GPS, all Google Maps, and just keep it there. It will show 100 cars are stuck in that road. That entire area will be painted red in Google Maps. So now that's a fake data, right? So then you should teach a program how to detect some kind of thing. If 100 signals are coming from a small location, that is not possible to fit 100 cars in this. As a programmer, this is what you will do. Have a look at this. So defining area as a vector makes more sense. So we do that. So you need to understand something. In science, we do things because it is convenient. Correct? We do things because it is convenient. Now for tensors, right, we have some quantities. We will not talk about them. There are something called, mode of inertia and all that stuff. So these things, right, not only depend on the direction, but they also depend on orientation. For example, if you take your water bottle, right? Let's say if you just take your mobile phone here, and if you try to rotate it in different directions, let's say if you take a mobile phone, now see if I catch it here, and if I try to rotate like this, that feels okay. But if I catch like this in the center and rotate like this feels different. It's the same mobile phone, right? If I catch the mobile phone on the corner and try to do like this, isn't it more difficult to hold? If I hold it here, it is more easy to hold. Is it the same mobile phone? Why am I finding to hold it more difficult when I'm catching on the edge? When you catch on the edge, it is more difficult. So if you see, it is depending on some quantity, which is not only mass and direction, but it is also depending on orientation here. Now, there are quantities like that called tensors. We will not deal with it. Right? At our study, that it's actually very complex to study, so we'll not get into it. Even in, like I said, right, if you're in engineering, mechanical, and civil people only learn that. Electrical people, computer science, we don't learn stuff. So yeah. Clear with this stuff? What's a vector? Now we defined what's a vector. We will go ahead with the representation. So we need to represent it. So anytime you should always have two things. One, a technical definition, and one, a layman definition for you to understand. So representation of a vector. So there is a first way of representing. Pictorial representation. So this is how we represent this. Whenever you have a vector, we represent with an arrow and a body. So here we have a body and here we have a head. So here the head gives the direction. The length of the body is proportional to magnitude. So the bigger the vector, the longer you have to draw. Example, if you say this is 1 unit, the 2 units should be bigger, 2 times the length. So this is a pictorial representation. Next thing is symbolic representation. So if you simply write A, I will think it is scalar. So if you tell me, right, we have a quantity A which is equal to 10, so we will assume it to be a scalar. Then if you write something as A bar, if you put an arrow on the top, this is how we pronounce this, A bar. This is written as a vector. If you write A cap, so this is how we pronounce A cap. The meaning of this is a unit vector. The meaning of unit vector is it's a vector with magnitude 1. And if you write mod a bar, again, this we pronounce as mod a bar. This means it's the magnitude of a vector. Have a look at this. Easy stuff, just definitions. Yeah. Now here we define few things. We write this as I cap. The meaning of this is it's a unit vector along x-axis. This is j cap. This is unit vector along y-axis. Then we write k cap. This is a unit vector along z-axis. Let's see how to use this stuff. Remember Cartesian coordinate system? Something similar, it looks like that. All clear with this page? Ashmit, Devan, keep your cams on. Turn in the page. Shashwat, clear na? Brijesh, clear?
Yes.
Ashwin, clear na? Position vector. Vectors is quite important. Literally every chapter you encounter this. Position vector. If the tail of the vector is placed at the origin, the head represents the position of the point. The head represents the position. So pretty basic stuff. So if there is a point P here, remember in Cartesian coordinates, the address is x comma y. Now in vector form, what we write it as, so we write like this. So the vector, see, look at the meaning of this OP bar. The meaning of this is we are going from, the arrow indicates that we are going from O to P. That is the meaning of OP bar. If you write PO bar, means you're going from P to O. You get in how to, what is the meaning of that symbol? OP bar meaning you're going from O to P. That arrow tells you you're going from where to where. If you write PO bar, it tells you the arrow is from P to O, meaning you should draw the arrow like this. So that's the meaning of OP bar. This is given by X I cap plus Y J cap. Let's try to understand the meaning of this. The meaning of this is when you write like this indicates, remember normally what we write x comma y? Walk x units along x-axis and then walk y units parallel to y-axis. Isn't that how we write address? So instead of saying that, we are simply using I cap, J cap, meaning the moment you see the word I cap, this represents X I cap represents walk x units along x-axis. So that's what I cap represents. I cap represents the direction. It tells you which way to walk. When you say Y J cap, it says walk y units along y-axis or parallel to y-axis. Clear? So instead of saying walk x units along right and y units along y-axis, we simply say x I cap plus y j cap. It's like saying like this. Think of like this. Let's say I'm standing here. You're standing somewhere here. Let's say this is east, this is north, this is west and south. If I want to come to you and if I want to tell a direction, this is how will I say? Walk 10 meters east. From there, walk 5 meters north, isn't it? So I will say 10 meter east plus 5 meter north. So instead of saying east and north, we are saying I cap and J cap. Are you getting the convention of I cap, J cap? So the moment I say the person has walked 10 I cap, you understood. The person has walked 10 units, I cap matlab along positive x-axis. Is that making sense? That is the meaning of the representation there. So if someone gives you example, let's say point P is -3, -2, then in this case, the OP bar will be -3 cap, -2 J cap, meaning from origin walk -3. So this means -3I, walk along the minus I cap indicates negative x-axis. Minus J cap indicates negative y-axis. So walk 3 units along negative x-axis and 2 units along negative y-axis, and you reach the point OP bar. Clear? Then easy stuff. Clear with this pitch. Now, if you go for 3-dimensional, if you have a point here with x, y, z, so the OA bar is given by, let's take it as this. Let's say this is AX, AY, AZ. Matlab A ka subscript X, A subscript Y, A subscript Z. So OA bar is given by AX I cap. So basically X coordinate becomes I cap, Y coordinate becomes J cap, and Z coordinate becomes K cap. If you take the magnitude of the vector OA bar, which is length of the vector OA, you are just simply finding the distance formula. Is root over AX square plus AY square plus AZ square. If you want to find a unit vector OA cap, this is your unit vector. What's the definition of unit vector? A vector with magnitude 1 means you take the vector and divide by its own magnitude, the magnitude becomes 1. Meaning, for example, look at the meaning of this. A person has walked 5 meters east. If you divide 5 meter east with the magnitude 5, what do you get? 1 east, na? What did you get? You got the direction, isn't it? Which way did the person travel? East. So if you divide a vector by its own magnitude, what you're left with is only the direction. So that's one important thing. So whenever someone asks you the direction, the unit vector gives you the direction. Gives the direction of the vector. If someone tells you in which direction is A bar pointing, OA cap. Getting it? So example, it is like this. Let's say if I say a person walks 10 meters east. So if you take this 10 meter east and divide by 10, what you get is 1 meter east. So basically he's traveling east direction. So what we got is direction here. Think of like that. So OA bar is nothing but AX I cap, AY J cap plus AZ K cap by root over AX square, AY square plus AZ square. You can put that down if you don't know. That's how you find a unit vector, magnitude of a vector. Clear with that? So remember that if someone asks you find the direction of the vector, he's asking you unit vector. Clear? Next thing. Can I turn the page? Suppose instead of going every time from origin, you want to go from a different point, let's say A to B. Let's say A ka coordinates are AX, AY, AZ. B ka coordinates are BX, BY, BZ. So if you want to go from A to B bar, this is how we write this thing, A, B bar. Again, look at the meaning of that. A, B bar. So that arrow tells you you're going from A to B. So this is final minus initial. So final is B and initial is A. So BX minus AX, I cap, BY minus AY, J cap, BZ minus AZ, K cap. So whenever you want to go from one point to another, this is how you get the direction there. So AB bar ka magnitude is given by, so this thing can be split open. You end up with BX I cap, BY J cap, BZ K cap, minus AX I cap plus AY J cap plus. So this is nothing but OB bar minus OA bar. So you can, if you know two position vectors, you can simply subtract them, you'll get AB bar. The magnitude of this vector AB bar will be root over basically the distance formula. X2 minus X1 whole square plus Y2 minus Y1 whole square. So basically you have to take I cap ka magnitude, Y cap ka, J cap ka square, K cap ka square, and then root. So root over this component, and this component squares. This is even better than position vector because position vector only gives you always from origin. This will go from any point to any point you can take. If you want unit vector, what should you do? So AB cap will be take the vector AB bar and divide by its magnitude mod AB bar. There, have a look at this. Clear? Let's see some questions. I hope everyone is clear till here. Anyone not clear with anything particular, please ask. So these are the main formulas there, AB bar and mod AB bar. Clear, na everyone? Brijesh, Arush,
Yes, sir.
Siddharth, clear so far?
Yes, sir.
Yeah, basic stuff, all these things are. Let's see some questions.
Sir, can you show the previous slide once more?
Hmm.
Just a second, sir.
You can note that down in case you are not clear with this.
Yes, sir.
Done?
Done, sir.
So this is your x-axis. This is your z-axis. This is your y-axis. This is the cube of side A. This is your origin. This is A, B, C, D, E, F, G. This point is H, which is a midpoint of G and D. This point is I, the face of this thing. So basically I is the center of face B, A, F, G. H is the midpoint of GD. So find OG bar, find AE bar, find CH bar, find OI cap. Yeah, get them up. So before that, let me help you out with this thing. First, find the coordinates of all the points. If you find the coordinates, your job is done. Let's start with that. Draw a cube. Find all the coordinates. Meaning, just to give you a small help, I'll just start. Center origin is 0, 0, 0. This point will be what? This will be A, 0, 0. Like that, you have to find the coordinates for all the points, X, Y, Z. Because once you got the coordinates, these are easy, isn't it? B2 minus B1, I cap, is BY minus AY, J cap, and you're done. Getting the coordinates is the main thing. Let's get this, everyone. First, find all the coordinates. I'll give you a minute. Show you the coordinates. Let me help you with the coordinates in case you're getting confused how to find the coordinates. See, this is the logic. So at the origin, you have the coordinates 0, 0, 0. Now remember like this. If you travel along x-axis, which coordinate will change? Only x coordinate, isn't it? If you travel x, only x should change. So A, your O to A, you're traveling only x-axis. So this will become A, 0, 0. Now from A, if you travel up, now you're traveling in which direction? Y-axis. So only y coordinate should change. Are you getting the logic? Whichever direction you travel, only that coordinate will change. But remember, already A may x coordinate is already A. So this coordinate will be A, 0. Is that making sense? Now from here, if you travel to G, you're traveling in which direction? Z-axis. So G ka coordinate will be A, if you're traveling from here to here, you're traveling along Z. This will be A, A. Are you getting how to get the coordinates? So whichever direction you travel, only in that direction, that coordinate will increase. Remaining coordinates will remain same. Now, can you find the remaining? So using this logic, you can find any coordinates. Find for the remaining. Anyone is confused with this, please ask me. I'll explain you again. So start from the origin. If you travel along x, only change the x coordinate. If you travel along y, change only the y coordinate. If you travel along z, change only the z coordinate. How much ever you travel, that coordinate will increase by that much. If you travel 2 meters along x, the x coordinate will increase by 2 units. If you travel along y, it increases by y, and so on. Now figure out the remaining coordinates. I'll give you a minute. If you see, it's more of like a coordinate system only. Only thing we are calling I cap, j cap, k cap, you know. If I go from O towards E, I'm going straight up. I'm traveling only in y-axis, so 0, y, a, 0. The cube ka side is A, so zero, a, 0. So from here, if I go towards D, I'm traveling along z-axis, so 0, a. So there's no x-coordinate here. If I go from O to C, I'm traveling only along z-axis, so 0, 0, a. So from here, if I travel to B, I'm traveling along x-axis, so a, 0, a. What else do I need? I need H. So from D, if I travel towards H, how much am I traveling? Midpoint, right? I'm traveling only a by 2. So this guy would be a by 2, a. Is this making sense, everyone? What else I need to find? ICA coordinates for I. See what I'm doing here. So from A, I will go till the midpoint here. I'll go till here. So you're traveling along y-axis. So this guy will be a by 2, 0. And from there, I'm traveling towards z-axis. So that guy ICA coordinates will be a by 2, a by 2. Please check all the coordinates, everyone. There, now you got everything. All the coordinates you want. Now the question is, you need to find OG bar. You need to find AE bar. You need to find CH bar. And you need to find OI cap. So what is OG bar? So G minus O. So this guy would be AI cap plus AJ cap plus AK cap. So final minus initial. AE bar. So you should take E minus A. So E is O, 0, this thing. So this is 0 minus AI cap. Then A minus 0 J cap. Then 0 minus 0 K cap. So this is minus AI cap plus AJ cap. There's no K component. Any doubts on these two? Please check. Can you do CH bar and OI cap? Try, I'll give you a minute. So if you see, the main thing about the question is not the vector, it is actually finding the coordinates. You know the coordinates question is over. Please ask me if anyone is confused with the coordinates. How did I get any particular coordinate? You didn't understand the direction. Anything you're not convinced, you please ask.
Sir, can you explain H1 once again? That H.
H के लिए, how are you traveling? See now, I'm traveling from O. I'll go up to E. So what coordinate will change?
So Y.
Y. So only Y बढ़ गया ना? Then from Y I'm going to D. Which way I'm traveling?
So Z.
Z ना? Now see, that means यहाँ पे जो 0 था, that guy became A now.
Okay. Yes, sir.
Now from D to I'm traveling H. Which direction I'm traveling?
So this X only. Yes.
X. And how much is the distance? H is the midpoint. How much are you traveling?
A by 2.
A by 2. So X coordinate देखो, 0 became A by 2. So remaining coordinates will remain same. Are you getting it? Only that thing will keep on adding up. Whatever you're traveling, that will keep adding up. You don't change the previous coordinates.
Okay.
Sure? Yeah.
Yes.
Anyone else confused with anything, please ask. CH bar. So you're going from C to H. So H is final, C is initial. So H is A by 2 minus C is 0. Then this is A minus 0. This is also A minus A K cap. Yeah. So this guy is A by 2 I cap plus A J cap. There's no K cap here also. What about OI cap? So before finding OI cap, let's find OI bar. So OI bar is easy. AI cap, A by 2, J cap. The magnitude of OI cap will be root over A square plus A square by 4. Therefore, if you want OI cap, this is AI cap plus A by 2 J cap by this magnitude, root 5 by 2. A will cancel everywhere. You end up with I cap plus J cap by 2 by root 5 by 2. You can leave it like this. That's what I said. It's a unit vector. You have to divide by the magnitude. Please check everyone. Easy? All got this stuff? Anyone confused
Yes.
with anything particular? In I only, why there is no Z magnitude? Wait, I think I goofed up something. Yeah, I goofed up.
It will be A by 2, no?
Yes. You're traveling A comma. Nay, it is right only. I wrote it right. I messed up here. Oh, I know. I goofed up here. I took this point of the coordinates as I confusingly. Oh, I right. So this is A by 2 K cap. My mistake. So magnitude of OI will be root over A square by 4 plus A square by 4. That is A into root 3 by 2. Therefore, OI cap will be, A will cancel everywhere. I cap, J cap by 2, K cap by 2 by root over 3 by 2. Yeah. Right, Om. I took this as I. Actually, this is I. Clear? Maybe I should name this point something, I guess. Let's call it some J. That is not I. Easy? Let's see next one. Turn in the page. Anyone has any issue, please ask. Ashmit, clear with this? So this is your x-axis. This is your y-axis. So we have a particle here. So there is an ant here. So initially it is at A. This is O. So this ant is walking with a speed U. The radius of the circle is R. Ant walks on the circumference. With speed U. This is the condition at T0. Okay, initially it is 0. So after some time, what will happen? The ant will walk like this and will reach somewhere here at time T. Then the position vector becomes this guy. So position A is not constant, A is changing continuously. Find position vector of the ant after time T. There, I just taught you one concept today, for position vector, and we are just playing with that. Because if you know how to find the vector, then the remaining stuff. Answer should come in terms of u, t, and r. That's it. The ant is walking on a circle of radius r with speed u. So after time t, this is the ant ka new position. So find the position vector of the ant after time t. Any ideas how to get the coordinates? So I'll help you with the little things. Straightforward. Let this angle be theta. If that angle is theta, this is r. From here, if you drop the perpendicular, this would be your x coordinate and this would be your y coordinate. So we know x is equal to r cos theta, y is equal to r sin theta. Therefore, the position vector OA bar is nothing but xi cap plus yj cap. Great, but what is theta? What is theta? Till here, everything is nice. R cos theta I cap, R sin theta j cap. How to find theta? If I get theta, my job's done. Try, I'll give you 30 seconds. Think about it. I need to find theta in terms of u, time, and r.
So is theta 360u by 2 pi r?
Nahi re. See now. So when you're traveling on this arc length, this is your arc length, isn't it? What is arc length? Isn't it the distance traveled by the ant? Arc length is nothing but speed into time, which is ut. And what is theta? Theta is nothing but arc length by radius. This is the first thing that we did in basic maths, which is ut by r. Done? Easy. The ant will travel how much distance? Speed into time. So in time t, the ant will travel a distance of ut, which is nothing but the arc length. Arc length by radius will give you the angle. Substitute there and you got the answer. So there, you got a vector which is changing with time. If something is changing with time, you can still use this vector. So ut by r I cap. Easy. Next one. Turn in the page. Next one. This is the top view. So we have a rod on the table. This is your x-axis. This is O, 0, 0. This is point A, which is 0, L by 2. So this rod, what is happening? This rod is going with speed, let's say 2 meters per second. And this rod is also rotating, let's say like, half revolutions per second. What should I give you something? Let's say this rod is rotating half revolution per second. Getting? Which is in terms of radians, it is pi radians per second. Every second it is rotating pi radians. So what will happen to the rod after some time? If you observe the rod motion, this is how it looks. After some time, the rod would become like this. Isn't it? A would come here. After some time, the rod would become like this. A would be like this. After some time, the rod would become like this. A would be here, and so on. You're getting how the point is going? So if you look at the motion here, this point is going like this. Best example, right? This is similar to pen game. Ever played pen game on a table? When you hit the pen, how does the pen go? It goes forward also, it rotates also, isn't it? This is similar to a pen game. You can just put your pen on the table and hit on the edge and see how it goes. It goes like this only. This is similar to the pen game. Getting it? So we have a rod here. So our rod is placed on a smooth table. This is the top view, okay? Right, which translates and rotates, means it is also going forward and it is also rotating. It does both. Find the position vector of A after time t. Literally, I'm asking you to find the coordinates of A after time t. Is the diagram clear, everyone? And just to give you a little more information, look at the meaning of half revolution per second. So this is what would have happened. If you look at the diagram in 1 second, this is the diagram at t is 0. This is O, this is A. After, let's say, half second, t is equal to half second, you will do how much revolution? 1/4 revolution, isn't it? Meaning the rod would become like this. This would be O and this would be A. This would have done 1/4 revolution. Because 1 second may you do full revolution, in half second you 1/4 revolution. If you take t is equal to 1 second, the rod would have completely got inverted. A would be here, O would be here. This would be half revolution. You're getting how it is? If you take, let's say, t is equal to 2 seconds, the rod would come back to the initial position. So in 2 seconds, you complete 1 revolution. So the rod is actually continuously going forward and rotating also. Is that making sense? Can you tell me how will the rod look at 1/3 second? 1/3 second, how will it look? So if t is 1/3, how it should look? Unitary method, no? Half revolution in 1 second. So what is the revolution in 1/3 second? So this would be theta is 1/3 into half by 1. So 1/6 revolution. Agreed? And one revolution is how many radians? 2 pi radians. So that is pi by 3. Meaning after 1/3 second, the rod would look like this. And the rod has rotated an angle 60 degrees. Is that making sense, everyone? One revolution is complete rotation, complete circle, which is 360 degrees, which is in radians. You can write one radians also. This is 2 pi radians. That also works. So half revolution is 180 degrees. So if you're doing 180 degrees in 1 second, 1/3 second will rotate how much? 60 degrees, no? Is this logic making sense? Everyone, rotation part. Now, can you do this for time t? I hope everyone understood how is the motion. Everyone clear with this, right? Let's get this. To find the position vector of point A. So literally, I'm asking you find the coordinates of point A after time t. Think, take a minute. So I'll do one thing. I'll make your life simple. Let's say find the position vector of A after time. Half revolution 180 now. Second. Let's make it 4 by 3 seconds. After time t is equal to 4 by 3 seconds. Let's get this. You do for 4 by 3. I'll show you for time t. Let's give you numbers. Or 180 degrees per second. So first draw how will the rod look at 4 by 3. The rod is going with 2 meters per second. The center of the rod is going with 2 meters per second, and the whole thing is rotating 180 degrees every second. So if you look at the path of A, it looks like this. It's going in some pretty weird path. This is the kind of questions we'll be doing later on. So no one will ask you find a vector like that only. Vectors will be a part of something like this. We'll be studying more complex motions. But for now, this is good. Everyone got the position? In 4 by 3 seconds, how does this look? So initially rod is here. So in 4 by 3 seconds, you will travel a distance of distance is speed into time, which is 2 into 4 by 3, which is 8 by 3 meters. That means this center, which is here, origin 0, this guy will reach here. It will become 8 by 3, 0. So 0, 0 becomes 8 by 3, 0. And what about the angle? In 1 second, you rotate 180 degrees. And 4 by 3 seconds, how much you rotate? So theta will be 180 into 4 by 3 by 1. This is 240 degrees. That means point A from here will rotate 240. The rod must have become like this. So this was the line. From here you rotated total 240. Does that make sense? If the total is 240, meaning this angle is 60 degree. This is the position of A. Please check everyone. Did I give you the length of the rod? I gave L by 2, no? Okay, that is fine. I can leave the answer in L's. Please check. This part is understood. Now can you think of what to do? So this coordinate is 8 by 3 comma 0, this center. A is here. And that angle is 60 degrees. Let's say I'll do one thing. Let's take length of the rod is 4 meter. Meaning OA ka length na is 2 meter basically. This is 2 meter. So O to A ka length is 2 meter. That I should have given you the numbers, but okay. How to find the coordinates? Just draw a diagram. You will see this. See. So this point is 8 by 3 comma 0. This is position A. This length is 2 meters. This angle is 60 degrees. So from here, if you drop the perpendicular, and if you drop the perpendicular, this opposite side will be 2 sine 60. This adjacent side will be 2 cos 60. Means it is 1 meter, and this is root 3. Now, think about it logically, isn't it done? So this point is 8 by 3 comma 0. To reach A, what are you doing? You're traveling 1 meter down. So what will be the coordinate? 8 by 3 comma minus 1. And you're traveling root 3 meters backward. So what will be the coordinate? 8 minus 8 by 3 minus root 3 comma minus 1. Is that making sense? That's your answer. That's it. So you're traveling from 8 by 3, you're going down and you're going left. You're going down 1, so y coordinate will become minus 1 and the x coordinate will decrease by 8 by 3 minus root 3. Is this making sense? All sure with this? Can you guys do something? I'll give you one more like this. So same question, you guys try this. T is equal to 4 by 3 and let's say T is equal to 7 by 6. Can you do for 7 by 6? I showed you for 4 by 3, na? You do for 7 by 6. Same question you do for 7 by 6. Any doubts on this, please ask me. Pushkal, Devansh, clear with this?
Yes, sir.
Yes, sir.
Archana, Ridal, clear? Siddharth, Kausambi,
Yes, sir.
Ashmit, clear? Great. Same question, try for 7 by 6. Find the coordinates of point A at 7 by 6.
सॉरी सर वो गलती से लेफ्ट हो गया।
Yeah, I felt so. You must have clicked something and went off. Chalo, try. 7/6. One by 6 minus √3. Okay. Let's see. So this guy was A. This was 2 meters. So the distance traveled will be UT, which is 2 into 7/6. So that is 7/3 meters. And the angle will be 180 degrees. You are covering in 1 second. You're doing 180 degrees. So in 7/6 seconds, you cover how much? Theta is 7/6 into 180. That is 210 degrees. That means this point A will rotate 210 degrees. So the rod would become like this. So this total angle is 180 plus 30. So this must have rotated 180 plus this. So this was 30 and that was 180. So total was 210, right? This length was 2 meters. So this is the opposite side. This is the adjacent side. So this guy would be 2 cos 30, which is √3. This is 2 sin 30, which is 1. Meaning you have reached 7/3, 0. From there you traveled √3 meters down. So it is 7/3, minus √3. From there you traveled 1 meter this way. So that is 7/3 minus 1. That is 4/3, minus √3. That is your Eka coordinates. Please check. Right, Arush, you got it. Hope everyone is getting with the angles. Please check. Home, clear this?
Yes, sir.
Others, any doubts on this? Let's see one more like this, but a little weird. Turn in the page. Can I go ahead? Anyone not clear with anything? Pushkal, clear, no?
Yes, sir. Clear, sir. Clear.
Brijesh,
Yes, sir.
great. Next thing. Now, before going ahead, let me explain your concept. If you have a wheel, we have done this in foundation. Right? If a wheel completes one full revolution, let's say if I take this point A, B, C, and D. So let's say if I mark them with different colors. Now, if I roll this wheel on the floor, initially, what's the first thing you will see? You will see red color. Then you will see green. Then you will see black. Then you will see this sky blue. You getting? So if I take this wheel and roll on the floor, you will observe in one full revolution, you come back to the same point again, A, B, C, D. So basically this distance would be 2 pi r. In one revolution, the center of the wheel travels 2 pi r. Agreed? Now, same thing, I can extend this. Suppose, let's say the wheel is not rotating full. Let's say this is point A. Let's say A comes here. What if the wheel has only traveled theta? Then how much will this distance be? The diagram is not up to scale. Let's say this is point A. Instead of full rotation, if wheel rotates only theta, that means this point A will reach somewhere here. This is O. This is O. It comes like this. So this length here shouldn't be this length here. So that means this distance will be how much? So if the wheel rotates by theta, the center of the wheel rotates by r theta. Making sense? If the wheel completes one revolution, it will rotate 2 pi r. If it completes theta, it will travel only r theta. If wheel rotates theta, center moves by r theta. Please have a look at this concept. Clear? So if you take the initial position of A, so if you take this position as origin 0, 0, the radius of the wheel is r. Find position vector of A when it rotates by theta. These kind of questions will be like a paragraph. They'll explain you some concept and they'll ask you something. Find position vector of A when wheel rotates by theta. Rolls by theta. Is this concept clear? For full revolution, you travel 2 pi r. Logic देखो ना, full revolution मतलब कितना था? 360 degrees or 2 pi radians. You go 2 pi r. For theta, you'll go r theta. Can you see that unitary method there? So whenever you rotate the wheel by theta, you go only r theta. If you do 1/4 revolution, the wheel also will go only 1/4 of 2 pi r. Can you find the coordinates of point A and get the position vector of point A? Get it? It's more of a geometry once you got this logic. Now, exam, they won't explain this much. They'll simply directly ask you the question. Exam question will be like this. There is a wheel which is rolling on the floor. This is point A, which is 0, 0. The wheel rotates by an angle, let's say, some 30 degrees or 60 degrees. Find the position vector of A. Means I'm asking you this guy. This is your position vector. Just let me draw the diagram for you. So this is A, this is O. So A has come somewhere here. So basically, this distance, I exaggerated the figure, it is this. So I'm asking you to find this position vector. I want you to find that vector. Right, you got 2 minutes. Anyone who didn't understand the scenario, what is happening, clear, ask me. I keep saying this. You didn't understand the question, it is my fault. Don't know what to do, that is fine. Try, you got 2 minutes for that. I hope everyone agreed with the scenario, right? When the wheel rolls, what happens? The center will go front also and the point A will come back also. Try. Quite useful this thing is. Later on, we're going to use this for a distance formula. There I'm going to ask you find the distance traveled by A, meaning this point A will actually go like this, like an arc. We'll try to find the length of that arc. And just to show you, how will the path look like? The motion of A, if you see, it looks like this. Why are you taking so much time today? This is how the path looks. Getting it? This is point A. So you're getting how it moves? So if you take a cycle car wheel and let's say if you tie a ribbon to the rim, this is how you'll see the path. It's not a circle. It goes in a pretty weird path. The A is actually jumping like this. So we are going to find the length of this arc. This red line ka length you're going to find later on. Then we are going to use this, the coordinates of A. Try. I'll give you a minute more. I'll show you then. Show you? See. So initially you're here 0, 0. Okay, and the A has reached here. And you're saying from here to here, you traveled a distance of r theta, meaning this coordinate will be r theta, 0. This point is your center. This is your OA. This is your angle theta. I can draw a little down. So from here, if you drop the perpendicular, this is radius r. So this length will be r cos theta, the adjacent side. The opposite side is r sin theta. That means what is this balance length here? The total radius is r. So it is r minus r cos theta. Agreed? Please ask me if I confused you. So indirectly, what you're doing is you have a point r theta, comma 0. To reach point A, you're traveling upward. How much? R minus r cos theta. And then you're traveling left side, r sine theta. Isn't that how you're getting A coordinate? So what is the coordinates of A? It is r theta minus r sine theta. That's your x coordinate. I'll write down that. So x coordinate of A is r theta. You're going back to minus r sine theta. Y coordinate of A is you're simply going up to r minus r cos theta. Done. So the position vector OA bar will be r theta minus sine theta I cap plus r 1 minus cos theta j cap. Please check. Is that making sense, everyone? Agar isme na, if you put theta is equal to 360, see what happens. If you put theta is equal to 2 pi, this will become r into 2 pi. Sine 2 pi is 0. This is r into 1 minus cos 2 pi is 1. So this becomes 0. This will become 2 pi r. Can you see? You'll get 2 pi r. That is the meaning, right? One revolution where you travel 2 pi r. So if you substitute different values of theta, I get different coordinates of A. So basically in this equation, this path which you're getting is for different thetas. Clear? So for this random path which we got here, that is the x and y coordinates of this point A, which looks like this. R into theta minus sine theta and r into 1 minus cos theta. Be careful, theta should be in radians. And keep this in mind. We're going to use this in kinematics. We're going to find the length of this arc using integration later on. For that, this is the starting bar. Any doubts? Anyone didn't get the coordinates, please ask. Think about it. Isn't this kind of motions which happen on a regular basis? This is a motion of a point on a wheel. We can play more actually. If you want, like it's like this thing. Ever seen how does the motion of a part on a fan look like in a lift? Motion of a fan in a lift. It goes in a circle and the lift goes up, isn't it? Motion is actually like this, a helix. So we can even find position vector of that also, but okay, we'll see later on. Any doubts on this? All clear? Let's see something more easy. Turn in the page. Kaushambi, clear, na? Mridul, Shashwat, Siddharth, Devansh. Clear? Arush?
Yes, sir.
Siddharth, clear, na?
Yes, sir.
Perfect. Next one. Let's say we have a vector OA bar. Now, every time we will write OA bar and all, we simply write it as A bar. So A bar implies OA bar. So when we are lazy, to write more alphabets, we do this. So 2i, let's say minus 3j plus 4k. And we have a vector OB bar, which we also call as B bar, which is I plus xj minus 2k. So we have a vector A bar is rotated by theta. You took this vector and you rotated by theta. And it becomes B bar. So you can rotate a vector and it will change angle. So it becomes B bar. Then find x. Theta is not given. Hope the question was clear. You have a vector 2i minus 3j 4k. After rotating, it became I plus xj plus minus 2k. So find x. How do we do this? This is a decent question. Again, based on concept of vectors only. Show you? Okay. Tell me one thing. If you take a vector, let's call this thing O A bar, and you rotated the vector, and it became B bar. I don't care how you rotated it. What remains constant? Something remained constant.
So magnitude.
Length, isn't it? No matter how much you rotate, length does not change. What changes is the direction. When you rotate a vector, the direction changes, the magnitude remains constant. Clear? So that is your important statement there. So vector will change because the direction changed. Rotating a vector changes the direction, but not the magnitude. So therefore, vector magnitude of A bar should be equal to magnitude of B bar. Don't say A bar is equal to B bar. Huh? I don't know that. Mod A bar is equal to mod B bar. So root over magnitude is 2 square, 3 square, 4 square should be equal to root over 1 square, x square, 2 square. Square on both sides. 2 square goes off. This guy becomes 25 and that guy becomes x square plus 1. So x will be 24, so plus or minus 2 root 6. Clear?
So it will be root 29 on left hand side or
ये 2 square इसको cancel होगा ना?
okay sir.
I just skipped a step. Want me to write that? I'll write down for you 29 and this guy is x square plus 5. Happy? Clear with this, everyone? Easy? So remember, this is the kind of a question you can get. Next thing. Any doubts on this? Anyone not clear with the concept? So when you rotate a vector, direction changes, but not the magnitude. Next thing, types of vectors. So that's about the position vector. Turn in the page. Yeah. Others do keep your cams on. First thing is parallel vectors. So a parallel vector is nothing but vectors with same direction. That's it, simple definition. If two vectors have same direction, we say parallel vectors, meaning if I say I'm walking 3 meters east, and if you say I'm walking 1,000 kilometers east, I don't care about the magnitude. We both are walking in east. So if a vector, we have A bar, and we have vector, let's say, B bar, you can say if A bar and B bar are parallel, then A bar is equal to K into B bar. So K is positive. This is for the parallel vectors. You can also write A cap is equal to B cap because the directions are same. Remember, unit vectors gives you the direction. So either you can write A bar is equal to KB bar, or you can say A cap is equal to B cap. So example, someone says A bar is I plus 2j. And if you simply write B bar is 3 times I plus 2j, so basically they're parallel. You just multiply the magnitude. They're parallel. Now, suppose if you have A bar like this and B bar like this, these are called anti-parallel. In this case, A bar will be equal to K B bar, but K is negative now. K should be a negative term. That's the only catch. So in this scenario, A cap will be equal to minus B cap. Check it out. Clear? Let's see a question. Any doubts on this? Let's say we have two vectors. A bar is 2i plus xj minus 3k. And we have vector B bar, which is 4i plus j plus yk. And it is given A bar and B bar are parallel vectors. Find x and y. Two vectors A bar, B bar are given. Both are parallel. They're not equal. Huh? Be careful, they're parallel. Find x and y. Okay, we have two answers. Anyone else? 7 by 2 minus 6. I don't, not sure though. Doesn't look right. Something is wrong. I don't know. Let's see. Anyone else got that answer? X is minus 6 and y is 7 by 2. We have one answer with that. Anyone else got the something similar? Opposite, okay. Remember what it is just now. Two vectors are parallel. That means A bar is k times B bar. So A bar is 2i plus xj minus 3k should be k times 4i plus j plus yk. Now, so this is 2i, this is xj, this is 3k, this is 4k I cap, this is k j cap, this is yk cap. So basically the x component should be same. The y component should be same. The z component should be same, isn't it? The coefficients of I cap, j cap, k cap must be same. So that means we got 4k is equal to 2. So what k is equal to half. X is equal to k. So x is equal to half. Minus 3 is equal to, sorry, I forgot to write, this is yk. K y cap. I should have taken some other constant, but he can. So minus 3 is equal to ky. But k is what? Half. So y is minus 6. Check. Half and minus 6. Easy. You're getting the comparison, right? A bar should be some constant k is a number into B bar. So multiply on both the sides. Now they became equal. So that means I ka coefficient, j ka coefficient, and k ka coefficient has to be same. Is that making sense, everyone? Easy question. But yeah, you have to think of it, nothing much. Have a look at this. Clear? There, one more thing here. Shifting a vector parallel to itself does not change the vector. Rotating a vector will change, but if you just shift it parallel to itself, it does not change the vector. Meaning, if you have a vector like this a bar, if you shift it forward, it is still a bar. If you shift it backward, it is still a bar. If you shift it to the up, it is still a bar. If you shift it like this, it is still a bar. Are you getting it? So vector you can move however you want, as long as you keep it parallel, it doesn't matter. Then we have equal vectors. Equal vectors are same. So vectors with the same magnitude and direction. So literally they're the same. There's nothing there. Basically, k becomes 1 in parallel vectors. Two vectors with same magnitude and direction. Then we have zero vector. It's a vector with zero magnitude and undefined direction. Basically, there's no vector. So a zero vector can have any direction. Clear? Rotating a vector changes direction. Let me add that also. Clear, everyone? So that is one. So there is one more vector called pseudo vector, actually, which we can discuss in circular motion also, but I'll give a little intro about that. So there are certain properties, right? Certain quantities which become very difficult to visualize with a normal vector. So we use something called a pseudo vector. And after that, we'll start off with a resolution of vectors. That's a quite important one. In entire vectors, that is one most important thing. Resolving a vector, and then we'll do some problems based on equilibrium and stuff, which we have done in foundation, but we're going to do a few of them again. Okay, so with that, we'll wrap up for that day, right? So make sure to go through these questions again once more, right? After the next class, I'll give you a small assignment also. I think we didn't do much anyway, so just basics and intro. Okay, so with that, we'll wrap up for that day. So any doubts in today's class? Anything else that you have, you can ask me, or else we'll catch up again on Wednesday at 8:45. So